Okay, good morning class. At this point we're still looking at exponents and surds. Yesterday I gave you homework on your exponential equations. So today we're going to look at more complex exponential equations. More complex exponential equations. Okay. And this example is on page. This example on page 9, but it's for exercise 1.5. Is that correct? These examples are for exercise 1.5. Okay. So now we're looking at the combination of skills that in the previous exercise solve the equations that are more complex. The example 1, and example 1 is on page 9. Okay. Example 1 is on page 9. And the exercise is on page 9 as well. 10. Okay. 11. Alright. So now we are asked to solve for x. We have 3 to the x plus 2 plus 3 to the x plus 1 equals 12. Okay. So if this was the sum, 3 to the x plus 2 plus 3 to the x plus 1, what would you have done? Would have broken it up, yes, and then common factor you would have taken out. So we're going to do exactly that. Okay? We're going to break this up. So 3 to the x plus 2 can be written as 3 to the x times 3 squared plus 3 to the x times 3 to the 1 equals 2. Okay. What is now common? 3 to the x. Okay, 3 to the x is common. Then what are we left with? 3 squared plus 3 to the 1 equals. You all agree with that? So what can be done now? You can simplify the bracket, yes? So 3 squared is 9, and 9 plus 3 is 12. So to get the variable standing on its own 3 to the x, I must divide both sides by. Okay. So what happens now? That cancels. Okay. So if that cancels, what are we left with? 3 to the x is equal to 1. People, anything to the power 0 is 1, not so? So I will choose 1 to be written as 3 to the 0. Therefore, x is equal to 0. And you can test it in the equations, you can test our solution. On the left hand side, wherever we see an x, we put a 0. And you will get an answer to our. Okay? Now we're looking at example 2. And example 2 is on page 10. Example 2 is on page 10. Okay. So here we again need to solve for x. We've got 7 to the x is equal to 7 to the x minus 1 plus 6 over 343. Right, what do you think is the first thing we're going to do? Sorry? We bring the 7 to the x minus 1 over to the left hand side. So 7 to the x minus 7 to the x minus 1 is equal to 6 over 343. Now what? Take what up? First break up 7 to the 2 to the x minus 1 up. Becomes 7 to the x minus 7 to x times 7 to the negative 1 is equal to 6 over 343. Now what do we do? Common factor. Okay? We take out the common factor. What's the common factor? 7 to the x. What are we left with? 1 minus 7 to the negative 1 equals 6 over 343. Now 7 to the minus 1 is 1 over 7. And 1 minus 1 over 7 is 6 over 7. So I divide both sides by 6 over 7. Now if you're that kind of girl that can't do that in your head or work it out on the page, what do we do? Use a calculator. Okay? So we say it's 1 minus 7 to the negative 1 is 6 over 7. So what do we say now? So that's going to give you, I think, 49, 7, yeah, it's 49. Okay? So it's 1 over 49. But say again you can't do that. Then we say 6 over 343 will be divided by 6 over 7. Which is 1 over 49. You will understand. Is there any confusion, people? Who's confused? Okay, what are you confused about? Division. Okay, you see here? This line means to divide here. So you're okay with the 6 over 7? Okay. So what we do is we say, okay, it's going to be 6 over 343 must be divided by 6 over 7. You see, many times you're going to put this whole complex fraction in the calculator, the learner enters it wrong in the calculator. Okay? So rather play it safe. If it's a complex fraction, you work out you write the numerator as a fraction and the denominator as a fraction. That's why I put the 6 over 343 divided by 6 over 7, which is 1 over 49. You understand? So what do we have at this point? 7 to the x is equal to 1 over 49. So what do I do now? Sorry? Right? 49 can be written as what? 7 squared. Then what? So we get to the top. So 7x is equal to 7 to the negative 2. Therefore, x is equal to negative 2. And again, you can test it. Okay. Any confusion at this point? Any questions? No? Now moving too fast. Okay. Let's look at example 3 for exercise 1.5. And this was on page 10, correct? So here we are given 2 to the 2x minus 3 times 2 to the x minus 4 is equal to 0. Okay? What do we notice here? Can we take out the common factor of 2 to the x? No? Let's take 4 over. Then it's going to be 2 to the 2x minus 3 times 2 to the x is equal to 4. We can't take 2 to the x out as a common factor. Remember, yes, there's 2 of it there. Can you see that, people? That, in other words, 2 to the 2x can be written as 2 to the x squared. Can you all see that? So I can't do what I did in the previous 2 examples. So what do you see? We see now a trinomial. Can you see that, people? I see that 2 to the 2x can be written as 2 to the x squared minus 3 times 2 to the x minus 4 is equal to 0. You all okay with that? So what I do now is say, okay, we got 2 to the x. We're going to substitute something into 2 to the x to make it easier. And this is what we call the k substitution method. Okay? The k substitution method. So what we do is we say, okay, we let this complex number, which is 2 to the x, let 2 to the x equals k, or let k equals 2 to the x. So if 2 to the x is equal to k, what would the sum now be? K squared, yes, minus 3k minus 4 is equal to 0. So now we see a simple trinomial. Okay, now do we factorize trinomial? Trinomial factorization. You think we left it in grade 10? No. For those of you at this point can use a quadratic formula, you can do that as well. Okay. But for this point, we're going to use the quadratic form. We're going to use the quadratic factorization. That's going to be k and k, 4 and 1. But what is k? Sorry, 4 and 1. So 1 must be plus and 1 bracket must be minus. The bigger one has to be minus. So 4 is going to be negative, that's going to be positive. Now what? So we say k is equal to 4 or k is equal to negative. But remember, what was the question? The question was to solve for x and not k. So what do I do now? Yes? You say substitute k back, yes. And 2 to the x equal to k again. So k will be 2 to the x is equal to 4 or 2 to the x equal to negative 1. Right, let's look at 2 to the x equal to 4. What can be done on this equation? 2 squared, yes. So 2 to the x equal to 2 squared. Therefore, x is equal to 2. We've got 2 to the x equal to negative 1. Can that work? No. So what do I write there? No solution. Okay, you guys understand? So do it again. Okay, so let's do it again. So again, the question says solve for x. Okay, and we have 2 to the 2x minus 3 times 2 to the x minus 4 is equal to 0. So as you can see here, this is not similar to examples 1 and 2. However, we know that 2 to the 2x can be written as 2 to the x squared minus 3 times 2 to the x minus 4 is equal to 0. So what do I do now? I introduce k. So what do we say? Let k equals 2 to the x. You can't just bring k into the story. You must introduce. Okay? As you do with your x's, no? Right. So let's go with it. So we say, if k is equal to 2 to the x, so this will be k squared minus 3 times k minus 4 is equal to 0. So what is that to us now? A basic trinomial. So what do we do now? Factorize. So you can use the quadratic formula if you're exposed to it at this point. Otherwise, we use the basic factorization rules. According to the factorization rules, if the last term is negative, one must be plus, one must be minus, and the sign of the middle term will be on the bigger product. Okay, with the bigger product, take the sign of the middle term. So it's going to be negative, so it's negative 4 plus 1. So we solve the two solutions. So k is equal to negative, positive 4, or k is equal to negative 4. But what is k? 2 to the x. So 2 to the x is equal to 4. And 4 can be written as 2 squared. So therefore x is equal to 2. The other end, k is equal to negative 2. So 2x is equal to negative 2. Can that happen? Can that be the case? No, the bases will never be the same. Therefore, no. Alright, you guys understand?
Yes.
Alright. So with that you should be able to do exercise 1.5. At this point we'll stop the video. The full lesson to this exercise will be found in the description box, please.